Hello guys, in this video we'll be discussing about the logical connectives itself. So in the past video, this video is the connective of the past video. So merge the videos and see. We have discussed in the previous video, we have discussed the logical connectives, that we have dealt with the negative conjunction, disjunction, implication, as well as the biconjunctional. Now what we will be seeing is that we will be representing each and every symbol using a what it definitely implies and the technical term they have used, and using a representation in a tabular format, so that it will be easier for you. Then later we'll be discussing about the properties of the logical connectives or the propositional logics. So let me take the tabular representation. So tablet representation, connective symbols, word used, technical term, and last one is the representation. So what is the connecting symbol? That it is a conjunction or disjunction. So these types of symbols. So what is the symbol represent? Symbol represent is nothing but the conjunction, which is what is this represent? It represent the word and. Technical term, conjunction. How do we represent it? Represent it within a conjunction B. So this is the representation of the conjunction. So what is the symbol represent? The symbol represent the disjunction. Disjunction is nothing but the or, and technical term disjunction. So representation A disjunction B. So coming to the another one is nothing but the implication. So what does it imply? It's called as implies. The technical term is used is nothing but the implication. So representation A turns to B. So next one is known as the biconjunctional statement. So we say that if and only if. So if the event occurs, there should be a certain parallel event which should definitely occur. That is why if and only if is known as, technical term is known as biconjunctional. How do we represent A? Biconjunctional statement B. So this is a representation. Then last one, nothing but the negative. So negative negation can be represented like this, or in some of the textbook they have provided like this. So based on your usability, you can use any of them. This is known as the not symbol, and basically the technical term is nothing but the negation. And how do we represent negation A or negation B? So this type of representation we'll be doing in logical connectives. So I hope you from the table you have understand how to use and what is the general term, etc. Now let us define the properties. So what are the properties? General properties are nothing but associative, commutative, identity, distributive, de-Morgan. These are some properties of the logical connectives, and later we'll be dealing about the limitations also. So coming to the properties. So what are the properties? First one property is nothing but the commutative. So what is commutative? Either neither A or B. When they change the places also, what will happen? We'll be getting the same answer itself. So that is what is commutative. For example, A and B is also known as B and A, or A or B is also known as B or A. So this is commutative. So coming to the second property, that is associativity. So what is associativity? Associativity is nothing but the whether you use different symbols or same symbols when the parameters are there. For example, when you add 2 plus 3 plus 4, when you add 2 plus 3, what will be 5? 5 plus 4, it is 9, right? Or if you add first these two terms, that is 3 plus 4 is equal to 7 and 7 plus 2 is equal to 9. So we have got the same similar answer. So associativity is nothing but this one also. This is also called as associativity, where we'll be having the same symbols for it. Let me define P intersection Q or disjunction Q intersection R can be written as P intersection of Q intersection R. So this is one of the representation, or considering the R, P P Q V R, or so let me write it, P or Q or R is equal to P or Q or V. So this is a what associated is. Whether you add these two or the this one, the value will be same itself. So that is what associativity is. Coming to the second one, that is identity. So what is identity property? Identity property is nothing but for example, in mathematical we'll be telling identity as 1, but coming to the propositional logics, P, any term is is AND with the true, what will be getting? We'll be getting the P value itself. But when any statement ORing with the true, we'll be getting a true value, because 0 1 will be definitely getting 1, 0 into 1 will be getting 0, 0 and 1 will be getting 0. So that is what identity property is. Coming to the distribution, so distribution property we say that we have to distribute each and when a certain group of word, there we will be distributing the value to each and every, so that the value doesn't change. For example, consider P intersection of Q or R is equal to, now we can write P intersection Q or P intersection R. So that is one of the representation, P intersection Q or P intersection R. So this is the representation, or you can take P or Q intersection R can be written as P or Q intersection P or R. So this is what the distribution is, distribution properties. So coming to the De Morgan's law, De Morgan's is nothing but there is proposed two laws, that is negation of anything will be given as a negation of given as sum of its negations, that is De Morgan's. So what is De Morgan's two laws? So De Morgan says that negation of P intersection Q will be granted as negation P. So negation P into negation, what is the symbol? The symbol is AND. Negation of AND will be or negation Q. Negation Q. Another one you have defined that P, negation of P union Q is equal to negation P or negation Q. So these are the two laws which De Morgan defined. So let us take a, so that's all about the properties of the logical connectives. Now let us talk about the limitations of the propositional logics or logical connectivities. So what we'll be saying that so we have seen only whether to say true or false, but when it comes to a group of people or all or some or none, this type of words are used in a statement, then we can't use a propositional logics. And propositional logics also have the limited expressive power, because we can't do more than 3 or 4 properties like them deriving the truth tables. I have didn't show the truth tables because it is very easy to derive it, so I have skipped the derivative part, but it just remember that it is expensive power. But in logical we can't describe the statement in terms of properties or logical representation, because when you talk about the tautology, when the tautology is nothing but the success rate of each event. So how many success rate of each event or the success rate of false event can be shown in a system, it is very difficult task, right? So that's all about the limitations. So let me note down limitations. So what are the limitations? We can't represent like, all, some, none. So these types of words are there. We can't use the propositional logics with propositional logics. So to implement anything with these terms, we have used another logic, that is first order logics. I will we'll be discussing it later. So this is one of the limitations. And propositional logics has limited expressive power. So proposition logic as limited expressive, because if there are so many variables, we can't find, but what will happen, that time will be taken more. So that is why it has only less expressive power. And coming to the last disadvantage, we can't describe the statement in terms of the properties or logical relations. So we can't say that if the ice cream is cool, we can't represent in a propositional logic. So that types also there is one limitation in that, in propositional logics. Propositional logics, we can't describe statements in terms of their properties or logical relations. So we can't represent their properties and the logical relation between the two components using the propositional logics, but we can combine the two statements using the connectivities. So that's all about the limitations. So let us recap from the past 3 courses what we have discussed so far. So we have started from the propositional logics. So in exam, if they give the question on propositional logics as well as the logical connectivities, write them from start to the limitations. So that is one question. It might be will be given for the 7 marks. So you might write each and every statement which I have told now. So propositional logic is nothing but it is a declarative statement. So it should be either true value or false value. So then later nothing but then later if the statements are all false, all true, it is called a tautology. And if the statements are all false, it is known as contradiction. Then later we have seen the syntax of propositional logics, that is either it is an atomic proposition or the compound proposition. Then later we have moved to the logical connectivities. In logical connectivities we have seen the 5 types: negative, conjunction, disjunction and implication and biconditional. Then later we have represented using a tabular format. Then later we have discussed the properties, that the commutative, associative, identity, distributive and T-Morgan's law. Just don't worry about the properties. In exam you can directly write these formulas, so don't mug up all those things. Then later we have dealt with the limitations. So limitations are 3 only, that is whether when repetition like all, some, none are given. So we can't represent in a propositional logic. To represent all those things, we can use the first order propositional logics. I will explain in my next video. Then propositional logics has a limited expressive power because we can't take for more than 3. It is very difficult to derive the entire truth table. When coming to the propositional logic, we can't take in terms of properties. And for example, if the sun is in red color, we can't represent that in a propositional logic. So these types of limitations are there in propositional logics. Later all these propositional logics have limitations have been rectified in the first order, second order, etc. So now later we'll be discussing. That's all in this video. Hope you like this video. Thank you.